All right, so given that it was my fault for having given the wrong idea and desire to learn, I am going to just give a hint and then put it back for another week. So
Will it replace the next homework, or will it be like?
it'll be in addition, of course.
Okay.
But you have another chance.
Okay.
So
Yeah, fine.
so we have this name string, and it contains some some name like that, right? And so, how do you find this space?
Index of.
How do you find this space?
Last index.
How do you find, so if I store this one, say, in I1, and this one in I2, and I know I have to call name string dot index of, and then the space, but I leave that part to you. Then how do I get John?
Substring 0, I1.
Is it I1 or I1 minus 1?
I1. I1.
Substring goes past the point.
Yes. Okay. How do I get this one?
Substring I1 plus 1, or I1, I2. I1 plus 1, I2.
You can just do I1.
I think it's just I1.
No, never mind. Yeah, there's a
yeah,
space.
right.
Well, it's easy enough to figure it out, right?
You're always going to be off by
So I'll put a question. Okay. And how do I get the last one? Okay, now I'm going to tell you a trick that's going to break your heart. If you omit the second parameter, it goes all the way to the end.
Oh, that's awesome.
All right, so now if I had to now implement middle, was get middle, say? Let me do get last first, it seems to be typing. So then it would look like that. So you get whatever index you need. You don't need I1 for the last one, but you do need the last index of. And then you just extract the substring and you return that. That's your answer.
I use the scanner and then in.next.
What he says is you made a scanner out of the, and you fed it the string.
Yeah.
You can do that. It's not what most people would do to solve this kind of problem. But yeah, it's nothing intrinsically evil with it. The book doesn't actually cover how to make a scanner out of a string, but it's fair.
Yeah,
If it works, don't worry about it.
Okay. But the thing is, like, I can't tell if it's middle.
Well, maybe then there's a good reason not to use the scanner. Oh, and there was this twist, huh? What was the twist? That we don't know if there's a middle?
Yeah.
Oh, the plot thickens. Okay. All right. So let's see how we're going to deal with that twist. All right. We're done with this one here. And let me have a quick look at the description of the thing, so I don't again tell you something that's.
And we can't use if statements.
That's right. So you can't, and I'm going to keep that, right? Even though now we're going to be doing if statements. Um, just to say that we can understand the trick here. Yeah. And we have a future access. Oh, I love this. So we have an optional. So the last name we're good, right? The last name with the last index of, that'll work in all cases. The first name with the index of will work in all cases. So now we have the trouble of how do we deal with the middle name? Did I give any hints? I didn't.
I think you think something about math.max.
Yeah.
Uh-huh. Okay, let's get a scratch paper here again. So we have I1, we have I2, and so normally I want to extract the substring from I1 plus 1 and I2, I think. Right, so if this was Fred, William, Smith, then I1 plus 1 is going to hit the W. So again, I1 is the index of the first space, I2 is the index of the last space. Now what happens if it was just Fred Smith? Then this one is going to be I1. And is it though? I2 is the last index of, where's I2?
It doesn't exist because there's no
Sure
space.
it is. I2 is whatever the full name dot last index of a space. So I take this thing, I look for the last space. Where is it?
Same.
Same, right? Same. So here's I2. They're the same. So what happens if I take the substring from I1 plus 1 to I2?
0.
Well, it's because I1's bigger than I2, so that can't be possible.
What happens?
Error.
What kind of error?
Out of bounds.
So you tried this?
Yeah.
You tried this and you got an index out of bounds exception, right? So the problem is, how do we avoid the index out of bounds exception? What answer do we want in this case?
The blank string.
Yeah.
So we want an empty string, right?
Yeah.
How could we extract the empty string?
We can use math.max on.
If I get the math.max, just in this case here, how do I get an empty string out of this?
We could use an if statement. I mean, like.
Right, except we can't.
Yeah.
So I have to extract from, say,
I2 or I1 to I2.
yes, that would actually work. If I went from I1 to I2, then that would work, right? So I want to be in a situation where in one situation, I go from I1 plus 1 to I2, and in the other situation, I just go from I1 to I2.
Without an if statement, though.
And if I was able to do an if statement, then I could do that, but I can't. So I guess the reason that I said math max is I must have thought of,
That's an if statement anyways.
what's that?
Mathemax isn't that just an if statement?
It's kind of like an if statement, except it occurred in chapter 4. And so we were allowed to use it. So the trick is that we have something of the form sub, and I'm just going to start at I1 plus 1 just for grins. And maybe it's not max max but max min, but we'll try something. So we want I2, or we want just to go to I1 plus 1. Let's see if it has a chance of working. How do I see whether this can work? Yes, I use the little boxes, I use actual numbers, because otherwise it's too abstract. So, okay, and over here I have so in my case over here, what is I1? 4, I think. So here I1 is 4. And what's I2?
12.
Okay. Over here, I1 is what?
4.
And I2 is?
4.
4. Okay, so now let's look at the first case here. Maybe I should do the second case in a different color. Let's do the green case first. In the green case, I do the substring from I1 plus 1 is
5.
okay, now I have the max here. I'll just write it as max here right now. What's I2?
4.
I2?
12. Oh, for the first one.
Yeah, we're still in the first one. And what's I1 plus 1? What was before? So I'm going from 5 to where? To 12, because the max of 12 and 5 is 12. And so I'm extracting the string as I want. Down here, I have the substring from, okay, what's I1 plus 1?
5.
And now I take the max of I2. What's I2?
4.
And what's the other one? I1 plus 1, so I1 plus 1?
5. So it takes the max of those, which is 5.
And I get the substring from 5 to 5, which is?
Just the last name.
No. What's the substring from 5 to 5? It's the empty string. It goes from 5 to 5, so it extracts no characters at all, and that is exactly what I want. It's brilliant, if I may say so. Right? So, how did I come up with this?
Magic.
I kind of had the idea that in this case I said, what blocked me is I went from 5 to 4, and that's how I got the exception. And I said, okay, to go from 5 to 4 is bad. I want to go from 5 to at least 5. And so the at least 5, that's where the max comes in. You pick the greater of what like your minimum threshold is, and then what the I2 gives you on a good day. So that was kind of the idea. All right, so ponder that. I will put it back in the hopper for you to finish. And so hopefully that'll get you going. I realize we didn't have class on Thursday, where you could have otherwise asked that question. Now, the topic of the next chapter is, of course, the if statement that makes these things a lot easier. So I'm not going to go into the basic if statement. It's perfectly straightforward. You have if, you have a condition, you have the good part, and you have the bad part. I will talk just briefly about this statement type business because it's confusing to people. And so when we look at the thing over here, you notice that I didn't put in braces in here. You have to put in the braces when there's more than one thing that you want to have happen in either the good part or in the bad part. You can put braces, and there's some programmers who recommend to always put them in, and that's not bad advice. So if you feel like it, you could certainly always put the opening and the closing brace after the if and after the else, and it'll keep you out of trouble. So when you have a statement that's composed out of more than one thing with the braces, it's called a compound statement, or more likely a block statement. So this thing is called a block statement. It just means do all of the things that are inside the braces. And so the body of an if has to be some other statement. In this case here, the body of the if is a simple statement. But then the if together is again a statement. And because it's more complicated, it's called a compound statement. So a simple statement is just a single thing followed by a semicolon. A compound statement is something that uses an if, whereas we'll see in the next chapter a while, followed by some other stuff. And a block statement is a bunch of statement grouped together with the braces. That's just somewhat useful terminology. And a bunch of the quiz questions went after that. All right. Now we're coming to some of the things that people find harder when we come to if statements. The example program here was going to print out when there are insufficient funds, and if there were sufficient funds, it was going to carry out the withdrawal. So, in the question, the self-check question is, why is it a less equal here? And why not a less than?
Because that way, if you want to take into account if the amount is also equal to the balance, not just if it's less than.
Yeah, so let's say this was a less than. Then what would happen? Let's say and again, I like to use actual numbers because it's more tangible. Let's say the balance was $1,000, and I withdraw exactly $1,000. What do I expect to happen?
You'll have just zero left.
Yeah, I should be allowed to zero out my account, right?
Mm-hmm.
But if there was a less than here, 1,000 is not less than 1,000. Then it would jump into the branch down here, and it would print out an error message saying they're insufficient funds. So that's what would happen. And so these kinds of errors are very, very common. That it's difficult for people to figure out the exact thing. Is it a less than? Is it less than equal? Is it less than something plus 1? And so it's very important that one checks that one uses the exact right symbol here. And so what people often do is they write a test case for it in the tester class, or they think it through in their mind. But writing a test case for it is actually always a good idea. And you'd be amazed how often one does these simple things just slightly wrong. Okay, what's wrong with this statement? So we're saying if the amount is less than the balance, we're going to compute the new balance as the difference between the two, and then we're going to set the balance to the new balance.
There's not supposed to be any code after the semicolon for the first one.
You can put code there, but the problem is it's not part of the if statement. The if is followed by a statement. That's the statement. So the way the compiler reads it is if, then it's going to do that. And that's the end of the if statement. Now, under all circumstances, it's going to do this subtraction, which is not good. How do you fix it? You have to put in a comma. So you use these braces. And now all is one. So that's again why many people recommend to just always put in the braces. That way there's no confusion.
And then it'll do everything in the blocks statement and everything in the brackets.
Yeah, so lots of people do that. They say with every if, they always use braces. And later we're going to see loop statements, and the book doesn't do it, but maybe the next edition will. It seems a student-friendly way of doing it. All right, relational operators are basically straightforward. We have these 6 operators, less than and greater, greater, less than look the way you think, less equal, greater equal. Well, they don't have a way of making the pretty mathematical operator, so they stick the equal behind it. It's fine. Equal looks weird. They use 2 equal signs. Why don't they use 1 equal sign? One equal sign is assignment. So when you say x equals 3, that means take a 3 and stuff it into x. If you say x equal 3, then that means look at x and look at 3 and see if they're the same thing. So that's the syntax that's used in many programming languages, in C and C++ and in Java. It's maybe a little bit unfortunate. There are other programming languages that solve this a little nicer, where for assignment they came up with a new symbol, and then for equality testing they used the same symbol that mathematicians have used for 500 years. So why does C and C++ do it in this way in Java? It's the S factor. Stupidity. It really was. That someone was not thinking straight, and the unfortunate thing is that people inherit this. Fortran was the first one that did it wrong, and C inherited it, and C++ inherited it, and Java inherited it. And it's been confusing countless generations of students. It's just life. So it would have been better to do it in this way, and some programming languages do that. Unfortunately, Java is not among them. So you just have to learn to use the equal for equality. After a few weeks, it becomes second nature, but right now it does look funny. And then for not equal, again, they were kind of stuck. There's no keyboard symbol for the equal with a slash through, and so then they use the exclamation mark equal. As we'll see in a lecture or two, the exclamation mark means not. Another surprising choice of operators. I mean, we think of the exclamation mark as something positive, but not in the morose world of programming where it means not. So, and the final pitfall that we're going to run into, oh, there's 2, yeah. One is comparing floating point numbers. I don't think that we're going to have this very often, but it does occasionally creep in. If you have 2 floating point numbers and you want to check whether they're the same, this is more difficult to do than you think. Yeah, case in point. So I'm having r as the square root of 2. Then I'm here multiplying the square root of 2 times the square root of 2 minus 2. Now square root of 2 times square root of 2 is 2, minus 2 is 0, so my expected result is 0. So I'm printing out here that says if d is 0, then print square root of 2 squared minus 2 is 0, and otherwise print it's not 0. What does it print? It'll actually print it's not 0, but 0.00000004 something. Some minute tiny number. And that is because the computation of the square root is not totally accurate. Then when you multiply it by itself, that's a little bit less accurate. Then when you don't hit exactly 2, you hit like 1.99999999996 or something. And that always happens with floating point numbers. It's just a fact of life. So when you compare 2 floating point numbers, you shouldn't check whether they're exactly the same, but you should check whether they're approximately the same. And so you want to check whether the absolute value of r times r minus 2 is less than some tiny number. Something like that. And that's just what you need to do. We will run into this once in a while when we do like a simulation. There's an exercise later where you shoot up a cannonball in the air and it comes back down on the ground. And it's not going to rest exactly on it. It's going to be approximately there. And for that kind of thing, you need to remember this test. Simply need to remember, whenever you compare floating point numbers, you can't just use equal, because the chance of 2 floating point numbers to be exactly the same is just so small. And the other thing is when you compare strings, something bad happens. So with strings, when you compare whether they are equal, then it tests whether they are the identical string object. And that's not very useful because you can have two strings that are different string objects, but they still are equal to each other. So let me motivate that real quick with an example. There's BlueJ here. So I'm going to use this nifty code pad that BlueJ has. So I've written definitions for S, T, and U. T is he. What's U?
E.
Okay. But they're not the same. Because this thing here is the string literal, and U was constructed by taking a substring out of another one. It was constructed as a fresh new object. They're not the same, and so that's a common pitfall. What you need to do is you need to use the equals method, which is more cumbersome, unfortunately. And that is true. So remember, whenever you compare strings, use equal. It's a common pitfall to use equals, and it gives you, sometimes it works, sometimes it doesn't work. So if I say, is T equal HE, it'll say yes. If I ask, is U equal to HE, it'll say no, even though U contains the letters HE in there. So all literal strings HE are the same, and other ones may or may not be. And so you have kind of the worst of all worlds. It's kind of random. You don't quite know when it passes, when it doesn't pass. So just simply beat it into your brain. Whenever you compare strings, you must use equals. Whenever you compare floating point numbers, you must use something absolute value less than some threshold. All right, that's what I have here. Let's go on into this lab.